So, are you still smarter than a Harvard graduate? If I sent a half sheet of paper around now, would you answer it correctly? Yeah? Good. Riley?
Didn't you say it's hot out the equator because of the tilt?
Nope.
No.
See?
No.
Oh no, it's gone! Chris. Angle of the sunlight, which changes between the poles and the equator because the Earth is round, because it's a sphere. There we go.
I said it.
You got it. Uh-huh. And then, if you understand that, only then can you understand this, right? The one the Harvard graduates got wrong is that because the sphere gets heated differently because it's a sphere, the Earth's tilt means, right, that either the top half or the bottom half of the Earth is going to be getting more direct sunlight, depending on which time of year it is. And so, this is only true twice a year at the vernal and autumnal equinoxes. Is that the right plural? I don't know. But every other time of year, it's more or less like this or this. What season is it in Ohio? Up here in this scenario? It is summer for us, and it is winter for the southern hemisphere. And what's it like up here this time of year? This is where day length comes in.
Isn't it day like all the time except for maybe like 1 or 2 hours?
Land of the midnight sun, absolutely.
And then on the South Pole, it's, I don't know why I didn't remember, on the South Pole, it's like dark, like 90% of the time.
Absolutely, and people go slowly insane. It turns out that you actually need sunlight in your life to be normal. They actually study people at the Antarctic research stations. They actually study the effects of sunlight deprivation because they go through it. The people that overwinter at those stations, it takes a special kind of person, by the way, to be one of those people. Then when you're this time of year, it's the opposite, right? It's dark all the time up at the north and light all the time down here. I can tell you from experience that makes it very hard to sleep when it's light all the time, but you have more energy, which is kind of cool. You gotta have really good blinds on your windows. So that is what we need to know about climate. There's more, of course, but that is where we're at with climate. But then there's a problem. Because you would think that if that was all there was to climate, why do we even have weather? Shouldn't we be able to accurately predict? Because we know the sun hits more directly in the middle than it does at the top and bottom. Okay, well, if you're at the equator, it's going to be this temperature, and go north, and it's going to gradually get cooler and cooler and cooler. Depending on what season it is, we can predict that, right? Why can't we? Why is weather so freaking hard to predict? The day-to-day conditions is what we're talking about with weather, as opposed to climate, right, which was long-term averages. Riley?
Well, in Ohio, it's because we can go from snowing one day to being 85 degrees another day.
That's what I'm saying. You're right. Ohio is crazy. Like, we can go from, you said, snowing one day to 85 degrees another day, but how can that be? If we're just heating somewhere in between, the North Pole and the equator, shouldn't we be like a nice 75 degrees all the time? Why is that so crazy? And the answer comes from the fact that the sun is not just heating the Earth. The sun is not just heating the Earth. What else is it heating? Differentially, more at the equator, less at the poles. What else does the sun heat besides the Earth? And by Earth, I mean ground. Right? What else does it heat besides the surface of the Earth, Abby? It heats water. And what does water do when it gets heated? Sometimes. What does it always do when it gets heated? Maybe not enough to evaporate, but enough to. Landon?
Doesn't it rise?
Sometimes, and then cooler air sometimes will sink, right? It's typically how it goes. The cooler water replaces the warmer water down there. But what it always does is move. Water moves when you heat it. What else moves when you heat it? What's the other thing on the earth that will move when you heat it? Air. And there you have weather. Mainly, the cause of weather is what we call heat transport. That's heat carried by air and water. Because air and water move when you heat them. And what do we call it when unequal heating causes air to move? Don't overthink it. Caleb?
I was going to say convection.
Convection is definitely the effect that's happening. That's the type of heating we're talking about. But what do we call it when air moves because it gets heated? You don't think of it this way. But when you step outside and the air is moving, what do you call it? That would be wind, yeah. Yeah, so wind currents transport heat and water currents transport heat. Do you know about Europe and how they have you ever looked at the latitude Europe's at? Like you think of France, right? You think of like the south of France is nice. That's like the French Riviera where everybody vacations because it's like beach weather all the time. That's the same latitude. Well, like the northern tip of Maine is the same latitude as the French Riviera. Is the northern tip of Maine beach weather? Almost never. Almost never. So what's going on there? What's going on is there's this nice warm bath of an ocean current that consistently washes up against the east coast of Europe. And it turns out that wind and water interact, right? If there's warm water washing up on the coast of an entire continent, that's going to heat the air that's moving across that continent. And it's going to basically make it warmer than it should be for its latitude. That's absolutely what happens in Europe. Water can heat wind. So there's another wrinkle for the poor weather forecasters when they have to do their job. The Earth also isn't a perfect sphere, right? It's bumpy. There's mountain ranges, there's valleys, there's all kinds of bumps on the Earth. So you got to deal with things like, well, okay, the weather generally moves which direction in this country? The United States, which way does weather go? West to east, yeah. Really, except for some of the weird circular patterns we see, predicting the weather in this country is usually as simple as calling somebody to the west of you and having them look out their window. That's what's coming to us, right? Well, as that happens, this nice warm Pacific air, comes over California and makes it the place where all the movie stars live. This warm, wet air comes over California and then gets forced up in altitude because there's mountain ranges all up and down, right? The east side of California. And all that air gets forced up. What happens when air gets forced up? What happens to the temperature? Gain altitude, lower temperature, right? And lower temperature means that air can hold less moisture. And so whoosh, down comes the moisture, which explains why you always see snow-capped mountain peaks, doesn't it? They're always snow-capped because that's the point where they drop all their moisture. Well, when that weather slides down the eastern side of that mountain range, it's lost all its water, which is why you see deserts beyond that, right? It's called a rain shadow effect, which is what makes the deserts in the kind of west central portion of our country. And then the final insult is that the Earth is constantly spinning, right? All of those together, those are kind of the major factors in our weather conditions, and they make it ungodly hard to predict. Weather's complicated enough that I am not going to talk really any more about it. I just want you to get a sense of the complexity. Like, for example, just for starters, as far as air getting heated by the sun, there's this. This is the beginning of the patterns of air, convection type currents that happen at the equator, because the equator gets heated the most, right? Which makes that air rise, but then of course the air is spinning, so it kind of spirals off. And there's these cells of air heat transport. It's a lot. So what I'm going to do instead is have you do some investigation on your own. I have the nice thing about NASA is they love to share their satellite data stuff. So I have like 5 cool little short videos of different aspects of climate that I'm going to have you kind of plug in and watch today that go with a worksheet that asks specific questions about each video. There's no sound on these videos, but I'll tell you what, this is one of those occasions where if you would like to get out your earbuds and kind of, these videos are, some of them are really pretty. If you want to listen to some cool music and, kind of zone out on these videos before you answer the questions, do it. The rest of the time is yours to work on that. If you finish these, then go ahead and work on your sample essay questions, please.